Alright, so what's the general form for an exponential function?
Like with a,
A to bx.
A can be
And-
came together.
Which variable represents the initial amount, Zach?
What?
Which variable represents the initial amount?
sorry, just me or is this
A.
freaking
Jordan?
desk was like digging in my lap.
Oh, I'm sorry.
Well,
I pulled it out.
if she knows the answer to the first one, she's gonna know the answer to the
Yep.
second one.
So which variable represents the growth rate?
B.
B.
Right? Is your name Jordan?
We grow by
She was taking
double
too damn
each
long.
time, right? Okay. Alright. So this is a good thing to put in your notes.
Just taking too damn long for you to die.
Jordan.
Hey.
Jordan.
You need to die alright.
Jordan.
Alright.
Stop.
Well,
It's not that much good. It's not that heavy.
That would stab into her, you know.
Go Will. Well, maybe
That-
she do.
Will.
Get retarded.
Will.
Just
Stop.
rub it behind your ear and then throw it at her.
Oh yeah.
When she gets stabbed in the face.
You're gonna have to edit the hell out of this freaking video.
Making it difficult for me. So,
I hope this is a thing about you.
last week we went over growth, exponential growth. Okay. Today we're gonna recover exponential growth because it's been basically a week since we talked about it. We're also gonna talk about exponential decay. Okay. So by the end of this, we'll understand exponential growth and exponential decay. So how about the general form for exponential growth? Alex, when we were talking about the Hudson Hornet, that was what we were talking about on this slide. So what was different about this one than our general form for exponential functions?
One of them is Jewish.
So the first part, this variable, which one are we using for this? A. But the B changed to something else, correct? It was 1 plus a rate, so we use the rate of R. Okay? So this is an exponential growth model. We talked about this on Wednesday for just recovering it. Okay? Alright.
I already have that note.
Yep. Where R is a rate, and it's usually a percentage. Okay? So it's usually a percentage. So if I had 6%, Zach, 6%, how do I write 6% as a decimal? Yeah. That'd be 60%.
0.06.
0.06. Okay. Alright, good.
That just fucked me up.
No, that's what I thought.
Now what feelings doesn't come often.
Alright. Jordan, you got that in your notes? You just from
You
Wednesday
know,
or from today?
your life and existence on this planet of the Earth
Justin?
is pointless.
Sonny, cut it out. Alex? Okay, so what's decay mean to you, Camry? What's decay mean?
Oh, yes, it's coming apart.
Coming apart? Okay.
Breaking down.
So you keep breaking down, okay? So you start with something bigger and it gets smaller, right?
Acid.
Okay, what's the difference between growth and decay?
One's acid, one's a tree.
Okay,
One's getting bigger, one's getting smaller.
okay, which one's getting smaller?
The tree.
And growth is getting bigger?
Acid. See, acid in a tree. Acid decays, the tree grows.
Ah, I understand, I get it. Okay,
Guys confused.
so we're gonna compare graphs. We've got an exponential growth, we've got an exponential decay.
What? The decay is on the right.
Decay's on the right?
I feel as if since we're American,
So this
left
one's
to
decay?
right.
And this one's gotta be growth?
Yeah.
Yeah.
Okay,
We're American, you know, bald eagle.
That's all.
Alright.
Alright, man.
I know that you said that just a minute ago. I'm saying I don't know how to find that
It's the same thing.
on the graph.
it is? Okay. Okay, so, the line, this one? Does it ever go below the x-axis? That means the range is all positive values, can't do negative.
Why do you get it?
So range is
Because
zero
started
to
drawing
zero.
like that.
I wasn't drawing my, look at my pencil like this. Oh, don't touch me. Alright, I'll just move the wiener on that poor skeleton face.
Can you put any number in there for x?
Yeah, I get fried in the electric.
There we go. Way off now. One
Well,
and
if
two.
it's-
Oh, okay, I get it now, I
This is
get
positive
it.
times x, right? And this is
No,
negative x?
I get
Two
it,
and
right?
one.
That's an
You
extra.
can put any x number in there.
You see that fine with the elephant?
No, that's
That's
the.
exactly.
Mr. Evans?
Yeah.
I got said that they've had to use this. I don't know any situations and they've told me no. Okay?
I don't get this. Well, who are you asking? Seven function at the interface. Way off.
Yeah.
What?
Right, so graph that.
So, on the calculator.
Mhm.
So how would you do that? Second, I just go away.
Please don't put it up there.
Okay, you're back.
Yeah.
Okay,
And then put it there.
maybe not after.
Okay. Okay, so what's domain?
No, thank you. Domain?
Yeah.
Domain is something. I had a bigger.
Domain is all
That was
of the numbers x that you can put into the function.
Active loop. I can feel it. I don't get what the domain is.
Okay. Any number x. So if we had, Zach,
Yeah?
so any number that you can put in for x is in the domain.
How do you know what number to put for X?
Well, when you graph it, if there's a spot that you can't put a value for x, so like, if we had something in it, we graphed it like this, and it looked like this, see there's a big gap here? We can't put any numbers in here for x. But if we have something that looks like
I'm
this,
just here to cheat off the freaking work.
we can put anything in for x. And that would be the domain. Domain would be all real numbers.
So, oh, I see now, we did it wrong.
Any number by x.
So any number x, so if the domain's the x values, what's the range?
Why?
The y values.
So what if it only goes through one number on one? I'm confused how you do Y.
So the y values, so what do a lot of our,
They all go through one.
they all go like this, right?
Yeah.
Alright? Do they ever go below this line?
Uh-uh.
Alright, so that means that y goes from 0 to infinity. Alright?
Always?
Yeah.
Alright.
A y. Alright, so we have, yeah?
Always.
Alright, so we say 0, infinity.
Infinite.
I don't think I did this right. How would you do?